You have the microphone?
Do you hear me?
We can.
Yes.
Okay, thank you.
Welcome. And Gian, did you want to try testing microphone?
Asking to send video.
Yeah, so since we're waiting and people seem to be a little bit confused about the controls, at the top left of your screen, you're going to see 4 icons. Starting left-hand side, a TV screen, a camera, and 2 microphones. The TV screen is for sharing the screen. We will be presenting the slides for the entire time, so you shouldn't need that. You're allowed to send video if you so choose. The microphone on the left-hand side with the hand icon is to request to join the audio queue. The microphone on the right-hand side is the active speaking, and you can sort of think about it as shouting over the microphone queue. We do request, in general, if you want to join the queue, use the microphone with the hand, and we will acknowledge you and let you speak at that point. We will be getting started in just a minute. Okay, it's currently 2 after. We have all of our speakers. So welcome to our online virtual Madrid for IETF 108. This is the BFD session. Next slide. Everybody should have seen the Note Dwell in more than one flavor this week. This is the standard template. You are expected to be bound by this, so if you don't know what this means, go read it. Next slide, please. So our agenda is relatively light. We'll be going over some quick chair updates. The 3 items that are up for discussion is an update on BFD for VXLAN, as gone through last call stuff. And we have 2 new presentations. Well, 1.5 presentations, one sort of a partial repeat from a prior IETF session. One is for BFD padding alteration that Xiaomin will be presenting, and BFD and affiliated echo Wei Chang, again, pardon if I'm mispronouncing your name. In terms of chair updates, we have several things that we're trying to clear through. General apologies, from me specifically for being non-responsive over the last several months. We've had the fun of the pandemic, and I also have had surgery that I was recovering from for my knee, so that took me out of the queue for a little bit. In terms of actual work, BFD for VXLAN still has an open discussion at ISG. I think that's actually been resolved. So I believe the -14 that Greg's going to talk about will likely address the last set of issues. We can move it forward. So we'll let Greg update us on that. BFD for large packets has gone through working group last call and is in need of a new revision. My intent is to push the changes that were requested last round. We will potentially discuss whether we want to hold back that document and maybe advance it with additional work as part of the upcoming presentation. The BFD for Yang document had a minor change for working last call to update for BFD unsolicited. At this point, it's now actually able to proceed, although we're seeing that, unfortunately, there's been a hiccup in one of the dependencies, the BFD tease document, and that will have to be resolved before the document can progress. BFD authentication documents, at this point, we're still waiting for the last sets of the Shepard comments to go through, and those can be submitted to the ISG as well.
So just a quick thing, I see that Rakesh is on the line. I believe, Rakesh, you're one of the authors of the Yang. I'll contact you and Tarek offline. Haven't looked at the detailed changes of the Yang yet. I'm hoping it's just a very minor change on the BFD side. On the authentication side, I see Santosh is here, but Mahesh isn't here. There's been no update to the sequence numbers document. I believe we want all three to go together. Thank you, Mahesh and Santosh, for accommodating my request. But we will need the sequence numbers document to be updated also before all three can progress.
Okay, and I believe that concludes our document status update. We have a couple of minor things that will be taken care of on the list afterwards. We'll pause here to see if there's any further comments or agenda bashing before we continue with the scheduled presentations. Greg, you have the microphone.
Yes. Thank you for the update. I have a question. We had a discussion at our last meeting on extended BFD work. And so we sometimes referred as BFD 2.0. So any update on that?
Yeah, that was one of the ones I was hoping to push off to the mailing list, but certainly we can have a brief discussion here. We approached the ISG specifically about what do we want to do about BFD2, or do we want to do BFD2? And there's sort of two broad topics that came up as part of that discussion. For the most part, question number one to the ISG was, do they care about BFD as a V2 specifically, and much like the rest of the ISG involvement for BFD, most of them don't understand what we do. So they're relatively neutral on that specific point. The related point of BFD V2 is starting to become a traction point for a lot of different proposals. And as I sort of discussed during our last session where we talked about BFD V2 and had our friends from IPPM come in, the point that we actually discussed was that they're not looking to have their technologies embedded in the BFD, and where this really left us was the interesting question of BFD is an interesting thing, much like BGP and DNS end up being interesting in their own areas. It's a useful technology that's well standardized for carrying stuff between two systems, and we did actually offer to the ISG as one of the options, BFD has a very nice constrained continuity check type activity that we want to continue to optimize for. This is where we've had our success. There's obviously interest in moving things forward to using the protocol machinery for other purposes, and rather than overload the well-defined use, perhaps we could consider spinning off basically a flavor of the BFD state machinery for more general purposes. And ISG was again, mostly silent on the issue, but they seem to think that that is a perfectly acceptable conversation as well. So my suspicion is that what we're going to end up with is basically a chartering discussion. My inclination, based on what we've seen over the years, is we do want to keep BFD a nice, tight protocol mechanism, stick to the primary continuity check case, and let us tighten our charter specifically for that. And if there's some other group or some other BOF that wants to spin off for BFD-like behaviors as a transport mechanism for other state information between systems, we're certainly happy to help people spin that off.
Thank you.
Okay. Other comments before we move to first presentation, which Greg is speaking for? Okay, being no further comments, Greg, please take it away.
Okay, thank you. As you probably know, if you followed the discussion with ISG, we had a lot of comments, a lot of discussions, and several versions were published to address these comments. Next slide, please. I don't go into details on all their updates that have been on the just the probably what most important. The first is that we received the comment and agreed to switch it to informational track, but we still maintain their normative language in the document. A lot of discussion was about how to guarantee that the BFD control packets are not leaked to tenants. And what we defined in the document and described is that the management VNI, which doesn't have any tenants, can be used to communicate, to send the BFD packets between VTAPs. Management VNI, we don't require the VNI ID, but we recommend to use it as VNI1. The next topic of discussion was that we had the text in the document that talk about the interaction between BFD and the firewall if it's co-located with a VTAP. And we received a lot of comments about it, that effectively we are opening their door too wide for it to be exploited. And agreed that, well, if you have this case, you can make it work. So thus, we removed this text. The text was a little bit too controversial and open to interpretations. We couldn't find agreement how to keep it, and removed it. Related to preventing BFD control packets being leaked is the question of destination MAC address on inner Ethernet frame. We had gone to different directions, and now we decided that we'll ask IANA for allocation of unicast MAC address. So that's the only IANA action that will be in the document. The second topic was the use of the choice of IP destination address in an inner IP header. It was very educational to me because from IPv4 we're all used to 127/8 range being used, especially in a tunnel case. RFC 5884 or 8029 and its predecessor MPLS LSP ping. So it's used to prevent packet being leaked out of MPL of a tunnel. And we usually map it to IPv6 range, and so I learned what their correct characterization of this would be. But interestingly enough, IPv6 doesn't have a range of loopback addresses directly correlating to 127/8. And it has only one loopback address officially defined. But what we agreed that we can use their correct characterization of IPv6 address as IPv4 mapped IPv6 addresses, and still recommend to choose destination IP address from this range. And another topic that we had is the question about their coverage of Echo BFD mode in BFD over VXLAN. If I remember correctly, so we asked the working group for the feedback, and the conclusion of this call for discussion was that it's not required, and thus in this document, Echo BFD is outside the scope of this document. what I want to point out and stress is that the use of management VNI. The document describes operation and encapsulation of the BFD control packet over management VNI. It does not preclude any other case. It's just they are outside the scope of this document. Next slide, please.
So Greg, one question on the destination IP address. It says inner IP header. That's outer IP header, right? Not inner?
No, it's inner. The loopback is used in the inner IP header. The outer IP header, it's a tunnel. So it has to be VTAP address.
Oh, yeah, okay. Yes, okay.
Okay, thanks. Okay, so a little bit more in details about management VNI. And again, the important part of management VNI that it's characteristic that it has no tenants. And thus, it ensures that there is nowhere to send to. Next slide, please. Yeah, destination IP address on the inner IP header. And it's recommended to be chosen from 127/8 range or IPv4 mapped IPv6 range. And it's may be used to generate the entropy. Next slide, please. I understand that BFD echo mode over VXLAN, we already have like indication of no interest in it. And the destination MAC address, the current text is that it's IANA action, and we are asking to allocate unicast EUI 48 MAC address. Next slide, please. So, as Jeff said, there is a understanding that at least all the comments that were open and questions after the first ISG review been addressed, and I hope that we are ready for the second round. Thank you.
Okay, we have people in the queue. Matthew, you have the microphone.
Thank you. Matthew Botchinock here. Just a quick question, Greg, if whether or not we had this discussion in MV03 with the BFD over Geneva about sharing fate between the BFD packets and the packets on the other VNIs. I'm just wondering if that issue had come up at all in this discussion about use for management VNI in the VXLAN case.
Right. So again, what this specification describes is the VXLAN tunnel continuity check. So it's not a specific VNI case. Per VNI is outside the scope of this document. So effectively, if using management VNI, we are monitoring that there is a way of getting from VTAP A to VTAP B.
Okay.
Whether we explore all possible paths that exist in the overlay network, no. This specification does not define that. It just defines that, again, that's what continuity check is. So it verifies that there exists a path between two systems.
Yeah, in principle, I'm okay with that. It's just that you may have situations where BFD goes down because of the way that the BFD, that VNI is hashed, but there is still continuity for effectively if you happen to be on a different VNI. So, I mean, This problem comes up all over the place, to be honest, when using BFD over LDP and all sorts of other cases where you've got ECMP. And I'm just wondering if it's worth saying something in the draft about that.
Yeah, we probably, again, I agree. It's an interesting problem, and we probably will be addressing it more in Geneva document.
Yeah. Okay.
So Greg, the management VNI was recommended to prevent leak of packets, right? Was that the main reason?
Well, again, because we define the management VNI as VNI that doesn't have tenants, by itself, it's a restraint which ensures that there is no one to send to. So it's, by the way, it's configured and provisioned on VTAP. We recommend to use VNI1, but it's an operator that can choose any particular VNI number just then to maintain its tenant-free.
But the reserve MAC should address that problem in non-management VNIs, right?
Again, if I look back in the history of this document, yes, that was an idea that if we have a dedicated MAC address that can be used to run BFD over non-management VNI. But we decided to keep it out of scope of this document.
Right. And as the shepherd for the document, a big portion of what Greg is discussing, Matthew, is the fact that we did have the document in a much more general shape for a very long time, where one or more BFD sessions could be testing individual VNIs rather than reachability between VTEPs. And a significant portion of the IESG feedback and pushback ended up being security considerations over how that impacted individual tenant systems. What do you set the MAC addresses to make sure that you don't collide with the tenant space, tenant IP addresses, and as anybody who's used to operating those sort of systems is aware, that's very much a question of provisioning and cooperation with the tenants to make sure that those things are set up appropriately. So there's some extent obvious to the people operating the systems what you should do, but trying to put it into a generic enough fashion that the ISG management was willing to say that the security considerations were sufficiently discussed was simply not happening, and therefore we took the spec back to test to the management VNI, which to some extent we're effectively defining in this document, since there seems to be no RFC that really talks about such a thing. And the important detail is that the packet format remains flexible enough that the other use cases likely can work perfectly fine. They're just simply not discussed in the core document.
Okay, thanks.
And it's worth noticing that the BFD for Geneva document probably should get a serious update once we finish with the VXLAN, because every single one of those considerations will pop up again.
Actually, since I'm cross on both and Xiaomin too, so we've been so he's a lead offer on BFD for Geneva, but we've been communicating, and I was updating him on discussion of BFD over VXLAN and changes that have been applied.
Okay, thank you. There's no further questions. We can proceed to the next presentation, which is Xiaoming. Xiao, you have the microphone.
Okay. Hello, everyone. It's Xiaoming here. This presentation is on BFD padding alteration. And this is a 00 version draft. Next slide, please. This draft is a supportive document to the current BFD large packets working group draft. It attempts to resolve an issue discussed on the mailing list and documented in BFD large packets draft. The solution is to add new procedures on BFD padding alteration. Specifically speaking, this draft extends the post sequence mechanism defining IETF 5880 to support a kind of a soft switch of BFD padding. Next slide, please. This slide copy-paste the text from BFD large packets draft to describe the issue this draft attempts to resolve. The issue is that due to some reason, the large BFD packets receiving system may drop the received packets, which would make the BFD session done. Then the operator uses the BFD function on both paths MTU monitoring and basic bidirectional forwarding detection. Next slide, please. This figure demonstrates the padding pole sequence that is proposed in this draft. Between the local system and the peer system, there is a BFD session running with small packets. After the operator turns on BFD padding at the local system, the padding pole sequence is triggered. Padding pole sequence is similar to the pole sequence defined in IETF 5880, but with some tweaks. Within the 5880 pole sequence, the pole packet is one of the scheduled BFD periodic packets. But within the padding pole sequence, the padding pole packet is an extra BFD packet. And the extra BFD packet has larger size than the scheduled BFD packets. If the padding pole sequence succeeds, the local system switch to send BFD large packets. The peer system remains to send BFD small packets. If the padding pole sequence fails, both the local system and the peer system remain to send BFD small packets, and an error would be reported by the local system. Next slide, please. When BFD padding is turned on at both the local system and the peer system, the padding pole sequence will be triggered in both directions respectively. The padding pole sequence in one direction is independent of the padding pole sequence in the reverse direction. And note that the packet size of padding pole response would follow the size of the scheduled BFD periodic packets. If padding pole sequence fails at one side or both sides, the BFD session remains running, and that's the main purpose of this procedure proposed in this draft. Next slide, please. Here are other scenarios when BFD padding alters, including increased BFD padding, decreased BFD padding, and turn off BFD padding. When increasing BFD padding pole sequence introduced in this draft will be used, and the padding pole packet with the increased size would be used. When decreasing BFD padding, pole sequence defined in RFC5880 would be used. The size of pole packet should be the same as the packet size after BFD padding decreases. The same mechanism applies to turning off BFD padding. In this scenario, the size of pole packet should be the same as the packet size after BFD padding turns off. Next slide, please. Okay, next steps. I ask for more reviews in the comments and revise this draft, and then ask for working group adoption. Thank you.
Santosh, you have the microphone.
Am I audible?
You are. Please
Yes.
state your name and affiliation.
Okay, Santosh from VMware. So when we say that we want to use poll and final sequence, how long do you think it will, use the poll and final sequence? The reason being that, once we have this poll and final, BFD packets are not absorbed in hardware anymore. It has to go to the state machine in the software, right? So what is the thought process on that?
Do you mean the timing for the poll sequence?
Yeah, how long do you think it will remain in poll and final sequence with the padding enabled?
I
guess-
don't know the exact timing, but I think it will be very quick because it's similar to that defined in RFC 5880. So
Okay, it is just for the negotiation that padding is enabled and disabled, right? That's all.
yeah, I think so.
Okay. Okay.
So
yeah, sure.
a follow-up to that question is, so what you're basically saying is when you would basically send a scheduled packet, and on top of that, you would send a larger packet with the poll sequence. So if your interval is 10 milliseconds, so you would send that extra packet until that poll sequence was resolved, until you got the F bit back.
Yeah.
So I guess the comment or question concern is, I think some implementations may have policers. So some implementations may, because you have a contract where you're saying you're going to be sending one packet every 10 milliseconds with 85% jitter or whatever it is, and now you're going to be sending more. So you may see drops of BFD packets. And having just reviewed the stability drafts and all that, that may show up as a BFD instability, may.
That may happen, yeah. I think extra padding poll can be sent more than once, just like a normal poll packet.
Okay, to interject a comment before Greg takes the microphone, BFD polling sequences, the protocol procedure is that as long as you're receiving the poll bit, you will continue sending the final bit until you stop seeing the poll bit. So this does mean that we don't have to see a small number of packets with this. The procedure can continue for as long as necessary until the other system has been satisfied with whatever it's checking. Greg, you have the microphone.
Thank you. Well, I understand the idea of using the poll is the frequency of the poll will be very relaxed and as a one packet per second. So it should not add significant number of packets to their fast session, which might have 10 millisecond interval for their asynchronous mode.
This is Jeff. So the poll while the session is actually up, proceeds basically at the previously negotiated timers. The poll procedure does give the ability to renegotiate the timers, and that's the expected way to do so if you need to. So what this would mean is that you continue at the same speed, and that's sort of my primary piece of feedback tying to what Rashad has mentioned, is that we're going, most BFD implementations tend to be packet per second limited rather than bits per second limited, and what we're effectively doing with large packets is changing bits per second, by having larger packets. So if there's a consideration about changing the packet the bits per second range and interactions with other systems, there's some concern there. That said, one of the things the BFD large document does mention is that you may be able to support fewer sessions because you've changed the scaling because of this. What that would mean for the proposal that Xiao is giving is that it may be necessary to change the negotiated session speed in such circumstances before you actually start probing for the large size.
Yeah, I understand.
I have a follow-up question to that. Have you, I mean, I took a look at the draft, but I don't remember all the details. Have you considered, as opposed to doing on top of, just replacing a small packet with a large packet and then setting the poll bit there?
Because the intention of this draft is to remain BFD running, BFD session running when BFD padding alters. So I think if I change the BFD packet size with the periodic BFD packets, then maybe that will cause the BFD session go down. So I propose to add an extra BFD padding poll, large BFD packets. The intention is to remain the BFD session running.
Yeah, if you're sending your large packets multiple in a row, that could happen. If you're kind of interleaving them, sending one once in a while, it could have that impact too if your small packets have been lost. Okay, thank you.
Okay, thank you.
Okay. And I have a final comment. This is speaking as the one of the authors of the large document. So I think, Xiao, what you're partially showing is that you're providing a mechanism by which we could negotiate large packets. This was one of the open discussion points that had come up from the working group last call. The document, as we mentioned in the status earlier, needs at least one more spin before we do anything. So one option, rather than having this as a separate document, is including this as a piece of negotiated procedure in the large document. Do you think you and your co-authors would consider that?
Okay. I can work with you on that.
Okay.
I'm glad to be co-author.
Excellent. And I think the final comment along those lines is use case driven. This is where I'm providing the outlook that Albert Liu, my co-author, has on what the need for this feature is. There will be some customers that will be happy to allow this to be a negotiated feature, and then there will be users of the feature that require this to be on, and the session must immediately fail if large packets does not work. So part of our discussion point for the working group is, what does this look like? Does it have impact on things like the Yang management module, etc.?
Okay, I see. Thank you.
I think there's no further comment on this. Next speaker, please.
Okay, so thank you, Xiao. Could you hear me?
Yes.
You're loud and clear.
This is Wei Sansheng from China Mobile, and this draft we have presented in last meeting, and Next page. The intention of this draft, we would like to propose a use case for BFD ICO function. It's a new use case that's not yet being documented in some other current FCs. And the BBF TR14 have some similar use case of BFD ICO function proposal in this draft. But in that TR, the procedural text is a little bit unclear. We will show that later. And we also have some discussion, had some discussion with chairs and other experts. We think the errata was not appreciated appropriate, and maybe an informational draft seems valuable. So next page. So this is the text in BBF TR146 use cases, and it's just given. It should be noted that the BFD ICO mechanism is only suitable to detect and recover from the loss of IP forwarding connectivity between the RG and the IP edge, as observed and detected by the RG. Next page we will show detail in the TR 146. Next page. So here we list some text from the BBF draft, which was in section 6.2.2. It gives some description, but it's not clear whether the BFD state machine defined in FC 5880 is applied to the local system, and it's unclear whether the BFD ICO packet reuses the format of BFD control packet defined in FC 5880. So that's why we drafted this document. Next page. So the proposal described in this page, the device A supports BFD state machine, which is down to initiate to up. The device A sending the BFD ICO packets to device B with the IP address designated for itself. BFD ICO packet reuses the format of BFD control packet with destination UDP port 3785 assigned in FC 5881. The device B doesn't support BFD state machine. The device B doesn't support the BFD control packet processing. It's just forward the packet as a normal packet. Okay, next page. So here we give deploy the use case in China Mobile's network. That is in our data center. Now a lot of operators have begun to deploy 5G network, and the 5G core network, which will be deployed in the telecom infrastructure cloud, and we have to guarantee the high reliability in the data center. That requirement even higher than the normal data center. So in this case, we use the solution we just mentioned. The DC gateway support the BFD state machine, and the virtual machine don't need to support any function of BFD. Using this solution, we can monitor the link between data center gateway and the virtual machine. That may be a OVS, something like that, virtual switch. The virtual switch located in the server, and it often cannot support high forwarding functions, forwarding performance. So if we don't need OVS support the BFD, that will save the resource in the virtual machine. So that is the first purpose. And the second one is that we often use different vendors' component in one data center, such as the DC gateway, maybe from a vendor, and the server or the OVS system from another vendor. If we want to set up the whole solution and support such as BFD, we need to have an interoperation test between the data center gateway and the OVS. And it's often very hard because there are many different vendors provide those different systems. So if we use the solution described in this draft, the decoupling between different vendors, gateway and OVS, very easier. So that is the value for this use case. We have already deployed this kind of solution. It works very well. So next page. Next step, we ask for more reviews and comments. And then we ask for working group adoption. That's all. This is an information draft.
Okay. Quick comment. We are near top of our session. We get kicked out very quickly, so we need to keep these somewhat brief. Rakesh, you have the microphone. Please state name and affiliation.
Hi, this is Rakesh Gandhi from Cisco Systems. Waiting. It's interesting work. Just want to bring to the attention that we are doing very similar work for TWAMP protocol, where we would do the loop back, and on the responder reflector side, it's unaware of the TWAMP state machine. So it's interesting to see BFD has a similar proposal. One question I had is, does it mean we would update the procedure for BFD defined in 5880? Is it like there is no point done, no inject done, but BFD responder or reflector is designed certain way? So does it mean we modify the base RFC?
Yeah. So thank you for your comments. I think as I know, there are some solutions based on TWAP also, but here I think we don't need to change any BFD solution in the local server, and we also don't need to change any functions in remote peer. So I think we just have some configuration for the BFD the BFD control packet with itself's IP address. That's okay. So I think this one is a simple way. And maybe in some other application scenario, if the solution have already support the TWAP, that may be the better solution. But I think for this application scenario, if the local node support BFD, that's enough. We even don't need to change the state machine or something like that.
And if I might interject, since we're a little low on time, prior discussion when we had this proposed the first time, a couple IETFs ago, this is a very odd document at the BBF level, just simply because we are not really using BFD in here. There's no state machine. This is strictly the echo function that may or may not actually have a BFD implementation at the back end doing the work of generating this echo traffic. So, Rakesh, your question's valid. Does this really update BFD? I think the proposal we have here versus the one from BBF is that we are intentionally talking about there's a BFD state machine on the local side that can actually handle the echo stuff. If that's the way this document proceeds, this would be an update to 5880.
Mm-hmm.
Okay, thanks.
Greg, you have the microphone? Greg, you have the microphone?
Okay, thank you. I would suggest to clarify one thing related to the multiplexing BFD sessions on a sender receiver. I think that since it uses well-known UDP port, so my understanding is it expects to receive the BFD packet. So I think what's logical is that the system assigns discriminator to this session and then puts this value in your discriminator packet that it transmits. So I looked in the document. I didn't find it in the document. I think that it will be helpful to clarify that part of the process.
Okay, yes, thank you.
Next one, I think, is Jagan.
Hi, this is Jagan from Cisco. I have a small clarification here. Is this looks like same as SBFD functionality, like which can loop on the receiver side? Is that what we're trying to do here, or?
If I can, Greg Mirsky, ZT again. In my opinion, it's not, because SBFD sends the packet to their remote site, which advertised its discriminator, and it could be, for example, learned through the IGP extension. And effectively, the remote site receives this packet and sends it back. So my understanding of this proposal is that the loopback works on the transport layer, so there is no reception of the packet at the remote side.
Yes, actually, even SBFD, there is a similar thing what I've said, right? It need not to go to the control plane. It could be loop back in the data path. So we have that kind of.
Then it's an echo. I would not characterize it as SBFD. It's echo mode.
It's Xiaomi here. I'm co-author of this draft. I want to clarify that or answer Greg's question. I think you are right. This BFD echo is actually a BFD control packet. So it uses discriminator to multiplex the received BFD echo packets and to a BFD session. So I think Yeah, it's a bit different with the current BFD echo defined in RFC 5880. But the state machine and the BFD control package are all the same to that RFC.
I would still consider that if you're running multiple sessions like this, you want to demultiplex them. And if you receive them as BFD packets, because your transmitting nodes is a receiving node at the same time. So I would expect it will be listening on this UDP port and wants to demultiplex the BFD packets. And if we follow the BFD process, so demultiplexing happens on your discriminator value. So I think that your discriminator can be locally assigned to this echo BFD sessions. So then the sender can monitor the state of the remote side by knowing which packets missed and which packets received, because that's my understanding what the purpose of this procedure is.
Right. And
yes,
based on time, yes,
Yeah.
we're going to have to cut the microphones because we are just about out of our time. We're 5 minutes over, and the tool will kick us out in 3. What I would suggest at this point in time is there's obviously a lot of interest and discussion in this. Just make use of the feature from the tool. Start a hum. If you have interest in issuing the working group adoption call, immediately, please respond positively to the hum, and we will take this to the mailing list as well.
Okay. Thank you, Chair.
Thank you for the presentation. Poll will end in 10 seconds.
Sorry, the voice is not good.
Okay. So the response of the hum, assuming that people understood what was happening, is come out as pianissimo, which is very, very quiet. So what we'll do is we will take this to the mailing list and continue discussion there.
Okay. Okay. Thank you.
Thank you, everyone.
Thank you, everyone. And we'll send out minutes hopefully fairly soon. Please contribute to them. And we will talk to everyone soon on the mailing list.
Thank you.
Bye.
Bye-bye.
See you. Bye-bye.
Thank you.